Okay, if you are in 7 Excel, we are working from the Advanced 2 textbook. If you are in Math 8, we are working from the Course 3 textbook. We are reviewing Chapter 1, Equations. Okay, so let's jump on in. Our first equation is 3 times 5x minus 3 equals 5 times x minus 1. Okay, this is a great problem because there's a lot going on here. The first thing we need to do, let's distribute. 3 times 5x. Well, 3 times 5x is 15x. Move on to the next. We have 3 times negative 3. And 3 times negative 3 is negative 9. My equal sign. We now have 5 times x, and that's an easy one. 5 times x is 5x. And then we have 5 times negative 1. And 5 times negative 1 is negative 5. Now, we need to combine our like terms. And I've got a variable on both sides, so I need to get them together. And it doesn't matter which side you decide to take your variable to. If you decide to have your variable on the left or the right, it doesn't matter. You will get the same answer. I just typically try to keep my variables positive. So I'm going to move this guy on the right over here to the left. So to get rid of him on the right, to get rid of positive 5x on the right, I need to undo it. So I'm going to use inverse operations. To undo positive 5, I need to use negative 5. What I do to one side, I must do to the other. So I've got 15x minus 5x is 10x. Everything else comes down. These guys cancel. Now I need to get my constants to the right. So I need to get rid of this negative 9 or undo negative 9. To do that, I'm going to use inverse operations. I'm going to add 9. What I do to one side, I must do to the other. So these guys cancel, and I've got 10x equals negative 5 plus 9. I'm going to subtract and keep the sign of my largest. Now, I still need to isolate my variable, so I need to get rid of this times 10. So to undo times 10, I'm going to use inverse operations, and I'm going to divide by 10. What I do to one side, I must do to the other. So these guys cancel, and I've got x equals 4/10. But the directions asked us to give our answer in simplest form. So that means we need to reduce this fraction to simplest form. Since 4 is an even number and 10 is an even number, I know I can reduce at least by 2. So 4 divided by 2 is 2. 10 divided by 2 is 5. This cannot be reduced any further. So there is my answer. X is equal to 2/5. 2/5 is the solution for this equation. Now, I like this equation because it covers a lot. It covers the distributive property. It covers variables on both sides and having to combine like terms. It covers multi-step equations because first we have to undo the addition and subtraction before we can undo the multiplication and division. And it also looks at reducing fractions. So this is a pretty good problem. It contains a lot, pretty much most of what equations entail. So let's take a look at another one. So we've got 1/7 times 14r plus 28 equals 2 times r, let me fix that, 2 times r plus 2. Now, do not let this fraction bum you out. You can totally handle this. This is 1/7 times 14r. We can handle that. 1 times 14 is 14r. 7 times 1 is 7. We can still make this easier to work with. What's 14 divided by 7? 2r. There we go. So that wasn't so bad. Let's do another one. 1/7 times 28. 1/7 times 28. Okay, 1 times 28 is 28. 7 times 1 is 7. We can still make this easier to work with. What's 28 divided by 7? +4. Okay. Now we have 2 times r. And 2 times r, oh, we can bring this one all the way down. 2 times r is 2r. And next, we have 2 times 2. And 2 times 2 is +4. Okay, we're ready to rock and roll. 2r plus 4 equals 2r plus 4. Huh? 2r plus 4 equals 2r plus 4. My left side is exactly the same as my right. And that's kind of true. If they're exactly the same, that means they're equal. Huh. Okay. Well, I'm not quite sure what to do with that, so let's work it out. I know I need to get my variables to one side, so let's do that. So I need to get rid of +2r. So I'm going to use inverse operations and subtract 2r. What I do on one side, I must do to the other. And this is quite an interesting conundrum. 2r minus 2r cancels. So I'm left with 4 equals 2r minus 2r cancels 4. And that is true. 4 does equal 4. They are balanced. They are the same. So this is a true statement. Therefore, this equation has infinite solutions. So what that means is, in the entire universe, the infinity numbers that we have, it does not matter which one of those numbers we assign to r. It does not matter which of all the, in the entire universe, the entire infinity of numbers that we have, we can use any one of those infinity of numbers and assign that value to r. And it doesn't matter which number we assign to r, my left side will always be equal to my right side. My left side will always be balanced with my right side. So we have an entire universe and an entire infinity of numbers to choose from. Therefore, we have infinite solutions. Okay, let's do one more. 9x minus 8 equals 8 plus 9x. Well, this is kind of nice because at least they're not making me do the distributive property. I appreciate that. So I need to get my variables to one side. So I need to get rid of this +9x. So I'm going to use inverse operations and subtract 9x. What I do to one side, I must do to the other. Now 9x cancels -9x. That's interesting. I've got -8 equals 8 because 9x minus 9x cancel each other. What? -8 equals 8? Now, I'm not exactly sure where you come from, but where I come from, -8 most definitely does not equal -8. This is a false statement. Therefore, this equation has no solutions. Que triste, no solutions. Okay, all three of these problems pretty much cover everything in chapter 1. Everything that we've learned about equations. Distributive property, combining like terms, variable on both sides, multiple step equations. It pretty much covers it all. So that's what we've got.